Hi guys, so today I'm going to show you how to get the hyperparameters for your best performing model. So this is a notebook that I made back in the fall. It's for hyperparameter optimization, and we're creating and training a random forest model, and we're using RDKit raw descriptors, so that's just going to help me figure out my output directory. So here's all the stuff to train the model. My result directory defined here is my home directory, then my random forest folder, and my RDKit raw folder within that folder. So as you can see for this, I did a grid search just to find the most optimized model. So we can scroll down here. Okay, so this is the function that you can use to sort for your best performing model. So as I said earlier, my result directory was my RDKit raw one. So I can go ahead and set this as my output directory variable, and then using the atom library compare models, I can find all of the models in my output directory that were regression models, and this is going to account for 348 models under this folder. So that's a lot of models. So I can go ahead and sort them by the validation R² score. So as you remember, that's the one that we care about the most for figuring out what our best performing model is. So I'll sort it in descending order, so the top one will be number 1. So if we look here, it outputs a table. If you look over here, here's my validation R² score. So my best performing model was a 0.454. So that's not too good, but I think I only ran this notebook once to kind of get a feel for what the grid search was like and to make an example. But you could definitely go ahead and keep changing some of the variables within the grid search to try to find ones that your model is more sensitive to, ones that it performs better on, and help you get a more narrowed search. So if you look at the first column, it's the model ID. This is what we'll need to know. So it just tells you which file is your model. And this here tells us our model path. So it's under my random forest folder and then in my RDKit raw folder. So I've actually already extracted the JSON files from the absolute top performing models. So I'm going to go ahead and do this for the second one. And it's not that much of a difference. It's like 0.001 of a difference. So here's the ID. I'm going to go ahead and copy the ID. Okay. And so this under the exact same model path, just in a different tar file. So the tar files created from the model training are gzipped tar files. So we're going to have to go to the terminal to unzip them. And it's also a little bit easier to work in the terminal in this case. So if you don't, I have a terminal open right here, but if you don't know how to open one, it's just, if you go over here on round to this plus, you click it, it's going to be under other, and it's going to be the first one that says terminal, but I already have one open, so we'll go over here. So if you take a look back, here's my model path. So what I'm going to want to do to start is I'm going to want to open these folders where I'm working at. So as you can see here, I'm just in my home directory. So to open up my random forest folder and then my RDKit raw folder, inside of that folder, I'm going to do CD and then home and then rwilfong and then rf RDKit raw. Okay, so as you can see here, this is highlighted, it's telling me my working directory. If you're also curious, you can do pwd. It'll tell you what your working directory is at the moment. So to go ahead and take a look to see what's inside of this, you can type ls, and it'll print out everything that's inside of it. So as you can see, here's probably the 343 models. So what you're going to want to do is you can make sure that the model that you're looking for is in there. So mine was, let me see, I forget, I think it was 8CA. So it should be over here somewhere. I wonder if I can, okay. I'm not making an assumption that it's there. Oh, here it is, 8CA. This one. So actually, I'm going to go ahead and copy this. So this is my gzipped tar file. So I'll copy this. What you can do now is you can take a look and see what's inside of it before you unzip it. So to do this, we'll do tar and then minus z tvf, and then I will paste that. And then so as you can see in here, it's my best model. And then these are the two JSON files we're most concerned for. So these are the ones that we're going to want to extract. So to kind of tell you what happened here, tar is to indicate that it's a tar file. And then the minus is kind of how you start your function. The z, it tells the tar file to decompress using gzip. The t will list the files in the archive. V is verbose, meaning that it's going to tell you everything about that file essentially. And then F is the last flag in that command. And so it's just saying that, hey, this is the last command. And after that, you'll put your tar file. So the mod OPRM1. So what we can do now is we can unzip it. So what we'll do is we'll do G unzip, and then I'll paste that. Okay, so to double check, we can type ls and see if anything happened in our directory. So if we scroll up, we see that we have, let's see, I should have unzipped, yes. So here is where our model was, and now instead of being gzipped, it's just a tar file. So that's a good indication. So what we can do now is we can extract the files. So to do this, we'll do tar, then minus xvf, and then we'll paste this, just get rid of the gz at the end. So the only thing that changed in this is so we got rid of the z and the t. So we got rid of the z and the t, we put an x. So the x just means to extract it. V is for verbose, and F is the flag for the end of the function. So this, if we hit enter, we'll go ahead and unzip it, or open up our tar file, extract all of the files, and it will save it to this directory. However, if you want to change what directory you're saving it to, after your tar file, you can do minus and then C. And then let's just say I want to save it to my home directory. So home rwilfong /. So let's give that a shot. So this is going to tell you everything that is moved. And then if I actually want to go over here and check, so this is my home directory on this side. Let's see if it worked. Let's see. And then let's do ls. Should be. Let's also do it to, what's another folder I could use? Let's see, Atom. We'll do it to the Atom folder, just because I already had one there, so I don't know if it actually worked. We'll do Atom. Gotcha. So we need to reopen this. cd home rwilfong rf get raw ls. Here's my tar file again, so we'll just go up here. Okay, now let's okay, yep. So I think it should be over in this file, yes. So, oh, that's right, okay. So it did replace the ones in the front, that's why I didn't see it. So in my home directory, it replaced it. But that's because it says from 3 months ago, and it's the exact same name as the one I unzipped earlier. So we can go ahead and we'll just open one in the Atom directory. So here I just opened this file called model metadata. So as you can see, it's got like the extended connectivity fingerprints. But here's the one that we're interested in, model parameters. So what you can do is you can check and make sure that the ID is correct. So it's 8CA, which is what ours started with. And you can see how it was trained. So here's the transformer key. It was ran on the local computer. This just says that it's regression. But here's our RF specific. So these are the hyperparameters that you're most interested in. So this one is my second best performing model. It had 164 for the estimators, 32 for the max depth, and 32 for the max features. So when you're recreating your best performing model on the new data set, you can go ahead and you can identify that. So actually, let me see. I think I know I have a notebook in here somewhere where I recreated it. Let me try to find it. Okay, so I'm not finding it. Oh, sorry, that's the wrong thing. I'm not finding it at the moment, but if you're interested in recreating it, if you go up here, when you're doing a grid search, what you can do is you can just identify the ones that were noted. So for my estimators, I could put 164, and for my depth and for my features, I could just put 32. And it'll only have one model to train, so go ahead and train that, and you can save that. And that'll be the one that will compare to our multitask models that we should have created by the end of this semester. And so that is how you would find your hyperparameters for your best performing model. Please let me know if you have any questions, if you need any clarifications. It can be kind of tricky working in the terminal, but once you get kind of comfortable with it, it'll be a lot easier, and it gives you a good experience working with it. All right, best of luck. Let me know if you have any questions or if you need any additional help, or if you need any clarifications. Have a great weekend.